We want to solve the equation sin 5 theta plus sin 3 theta is equal to cos theta for values of theta between 0 radians and 2 pi radians. It's easier to first solve the problem in degrees and then convert. If we're solving in degrees, we'll need theta to be between 0 degrees and 360 degrees. Since 0 radians is 0 degrees and 2 pi radians is 360 degrees. Let's look at sin 5 theta plus sin 3 theta. We know sin p plus sin q is identical to 2 times the sine of p plus q over 2 times the cosine of p minus q over 2. So the sine of 5 theta plus the sine of 3 theta must be identical to 2 times the sine of 5 theta plus 3 theta, which is 8 theta, divided by 2, giving us 4 theta. The cosine 5 theta take away 3 theta is 2 theta, then divided by 2 is theta. So the equation now becomes 2 sine 4 theta cos theta is equal to cos theta. As mentioned in a previous example, it would be a mistake to just cancel cos theta on each side. This is because we would miss out on some solutions. If we now subtract cos theta from both sides, we can avoid this situation. So we get 2 sine 4 theta cos theta, take away cos theta, is equal to 0. We have a common factor of cos theta, take it out, and the bracket has 2 sine 4 theta, take away 1. This tells me that either cos theta is equal to 0, or that sine 4 theta is equal to a half. Looking at cos theta is 0 for values of theta between 0 and 360, we should know that the correct values here are 90 degrees and 270 degrees, and you should really know this without having to work it out. Looking at sine 4 theta as a half, in this range, so 4 theta we need to look for solutions between 0 and 1440. So first looking for our principal value, the inverse sine of a half is 30 degrees. Looking at our cast diagram, A, S, T, C, 30 degrees is here in the A quadrant, and for a positive sign, the other one must be in the S quadrant. Solving in this range is equivalent to going 4 times around the cast diagram, although there are shortcuts that are possible. The first solution is at 30 degrees. If we're going around the diagram 4 times, we'll meet this solution 4 times. Therefore, we could just take the 30, add 360 to get the next time we reach there, add 360 again to give us the third time we reach this solution, and then finally add 360 again to find the fourth value at this solution. And we can do the same for the other solution. This one is at 150, and we could just add 360 3 more times in order to find each time we reach this solution. However, we'll just follow round on the diagram. If we go all the way round through 360, we meet this again at 390. But bearing in mind what I said before, note that 30 add 360 is 390. Continuing around, this solution is at 510 degrees. Note once again that 150 add 360 is 510. Continuing around, 720 add 30 is 750. And again, we get 870 degrees. Round through our third time around, so we're on our fourth time around, and this solution is at 1110, and then continuing on, this solution is at 1230. We don't meet any more solutions until we finish our fourth time around. Remember, these solutions are for 4 theta. To get solutions for theta, we need to divide each of them by 4. 30 divided by 4 is 7.5. 150 divided by 4 is 37.5. 390 divided by 4, 97.5. 510 divided by 4 is 127.5. 750 divided by 4 is 187.5. 870 divided by 4 is 217.5. 1110 divided by 4, 277.5. And finally, 1230 divided by 4 is 307.5. We want the solution to be in radians. To convert from degrees to radians, we multiply by pi and divide by 180. And we need to do that for each of our solutions. So, 7.5 times pi divided by 180 is 0.31. 37.5 times pi over 180 is 0.654. The next solution is the 90 degrees here. We can give this as an exact multiple of pi. You should know 90 degrees is pi by 2 radians. The 97.5 times pi over 180 gives 1.70 radians. 127.5 times pi over 180, 2.23 radians. Then we have the 187.5, and this will give us 3.27 radians. The 217.5 will give us 3.80 radians. The 270 is next, and we can give this as an exact multiple of pi, 3 pi by 2 radians. The 277.5 gives us 4.84 radians, and the 307.5 gives 5.37 radians.